Hello there guys, and then welcome to another brand new video. We are still solving questions on what we've done on probability. This particular question is quite challenging, and then I would expect you to really pay attention so that you understand the concept. The question says the following table gives the cumulative distribution function CDF of a discrete random variable. Remember, it is a function, right? It is giving us a function. Now the question says we have to find the probability mass function, PMF. You have to find the probability mass function of y, after which we can use that to compute these that we have over here. So you can solve at this point. You can pause, write down the parameters and try solving, after which you come so that we do it together. For those of you that this is your first time visiting this channel, this is Hub Beyond Numbers, and all I do is you give me your topics that you are finding challenging, then I'll do my best to explain them to you in ways you can understand. Let me know at the comment section how best I can help you, and if this video also is helpful, you can also choose to subscribe so that anytime I release videos you would always be updated. Now let's go to the question. Okay, so if you copied the question, then you would note that we're given functions, just functions. Now, it is important to know that the probability mass function of any random variable is derived or can be derived from what? The function, the probability distribution function. Now, there's an equation we use to do that. So if you want the probability mass function of any variable, any random variable, from your probability distributive function, that is f of y equals y, right? What we do is, you would first of all, if you want it from a function, so you would first of all find f of y, right? Then you subtract another variable that is less than it from it. What I mean is, so you are going to subtract f of y equals y minus 1. What this notation simply means is, if you want any probability mass function, then you are given probability distribution function. Then if you have f of y equals 2, then subtract f of y equals 1 from it. DC. That is how it is. So if you want that is f of y equals 3, then look for f of y equals, if you want p of y equals 3, then look for f of y equals 3 and then subtract that of 2 from it. Alright, so that is what we are gonna do in this video. So let me just quickly clean this so that we can then solve our question. So we are coming to solve it step by step. So we start with, for let me say y equals 1, and remember we're given a table of the probability distributive function, but we are coming to get the probability mass function. So for y equals 1, we say that p of y equals 1 would then be equal to f of, so f of 1 minus f of 0. You see, and from our table f of 1 was what? 0.4, but we weren't given f of 0, so we would assume it's 0. You know, anything out of that range we are given in the table is always 0. So minus 0, and that should give us 0.4. So we have gotten our first probability mass function, that is for p of 1, y equals 1. Then we come to p of y equals 2. So that one too, we are also going to look for f of 2 minus f of 1, and that is from the table 0.6 minus 0.4, which is equal to 0.2. Then we come to p of y equals 3. So it is also, just follow the same trend. So f of 3 minus f of 2, which is equal to 0.9 minus 0.6, and that gives us a 0.3. Then our very last one, so for P of y equals 4, we are going to get f of 4 minus f of 3. From our table, f of 4 was 1.0, and then f of 3 was 0.9, and that is giving us 0.1. So we have gotten all our values, you see. Now let's go back to the question, and then let's see what it really asked us to do. It says find the probability mass function, and we know probability mass function has two ways of writing it. First is the formula, and then the other one is the table. But from what we've done over here, it is just a table we can draw, you see. So let's draw our table. Drawing our table, we are going to have this here. Let me quickly draw a table here, then we'll input the values. So this here is going to be my table, where I would have my random variables here, that is y, and then down here I'm going to have my probability distributions for the various random variables. So from our solution we have here, we have the random variables being 1, 2, 3, and then 4, and then 4. So I think I don't need this table this side. So that of 1 was what? 0.4. So I'll put my 0.4 here. That of 2 was 0.2. That of 3 is also 0.3, and that of 4 is 0.1. You see? So that completes the first question. So this table here is our probability mass function. I hope that makes sense. So let's go to the next question. Now it says we should compute these over here. So the probability that our random variable lies greater than 1 but then less than or equal to 3. If you say greater than 1 but less than or equal to 3, then what we mean is it is actually greater than 1. The numbers greater than 1 are 2, 3, 4, on and on and on, but then less than or equal to 3. So this is omitted, and then we are just left with this over here. All right, so solving for this, let me create a new page. We are then going to get the probability mass function. So the probability, that was bi. So probability of a random variable satisfying this over here. We know that P of this here simply means we are looking for the probability of y being equal to 2, you see, plus the probability of a random variable y being equal to 3. You see, because they said it is greater than 1. Hence, you don't start from 1. And then less than 3, meaning you won't get to 3, but then they said or equal to. That is why we included 3. So evaluating, we are going to have probability distribution, the probability mass function of y being equal to 2 from our table that we solved. 2 is 0.2 and 3 is what? 0.3. So this simply means if you got this one wrong, then you are certainly going to get your subsequent question also wrong. You see? So you have 0.2 plus 0.3, and that should give us a 0.5, right? So that ends that also as well. Now let's quickly go to the next question. It says we have to find the expected value of y. We have to find the expected value of y. From our previous solutions, we said the expected value is given, so that is bi. So the expected value of a random variable is given by what? The sigma notation of all the random variables multiplying their probability distributions, their probabilities, from the very first one to the last one. So substituting and then solving. We have our first one was what? 1. So 1 times, what was its value? 0.4. So 0.4 plus the next one was 2. And then its value was what? 0.2 plus the next one was 3. Its value was also 0.3. And then 4's value was 0.1. You see, so if you are to evaluate, you are going to get 1 times 0.4, which is 0.4. 1 times 0.2, 2 times 0.2 rather, which is also 0.2, plus 3 times 0.3, which is 0.9. Then this also gives us plus 0.4. If you have to add all of this, we get 2.1. So our expected value is what? 2.1. I hope it has been very, very insightful. The only difference with respect to this one is that for this one here, this very first one, we are being given what we call the probability distribution function. And we are looking for probability mass function. You see, so this is something new. I think you would have to copy down. How do we get the function, the mass function from the distribution function? This is it over here. So if you want the probability mass function at y equals random variable 1, and to be the distributive function minus the preceding one. You see, so that is that for this section. Thank you very much for staying tuned. If there is any thing you want me to teach further to enhance your understanding, you can always let me know at the comment section. Have a blessed day. Thank you.